In Activity 12, Severe Storms, students examine several types of weather-related natural disasters. They first discover what conditions result in natural disasters, then practice forecasting deteriorating weather conditions, and finally, relate the importance of forecasting to being able to save lives and property. You will need the following materials from the kit. Activity Sheet 12. Piece of 23 centimeter by 30 centimeter construction papers. Paper fasteners. Hurricanes and tornadoes video, and weather stations. You will also need to provide markers, weather reports, storms handouts, and a VCR and TV. To prepare for the activity, make a copy of Activity Sheet 12 for each student. Cut the construction paper in half to make 10 centimeter by 30 centimeter pieces. Obtain literature on severe storms and natural disasters that are possible in your area. These handouts are available from your local Red Cross or your state emergency management administration. Have a TV available for viewing the video on hurricanes and tornadoes. Collect weather reports. Each team of 2 will need a marker, 2 paper fasteners, a half piece of construction paper, and their weather station. To begin the activity, introduce 2 types of severe storms. Tell students that hurricanes are hundreds of kilometers wide, making them the largest storms on Earth. They form over warm water and develop into huge masses of wind circling around a center. When these storms reach land, they usually cause great damage. Then introduce tornadoes as another kind of storm that creates very strong rotating winds, but that tornadoes form only over land. Hurricanes are rotating wind systems with wind speeds ranging from 74 to 200 miles per hour. The damage from a hurricane comes not only from strong winds, but also from storm waves and tides and flash floods caused by torrential rains. It is not uncommon for hurricanes to travel great distances and last for several days. A calm central core called an eye distinguishes this type of storm. The eye is surrounded by a thick wall of clouds. Hurricanes begin in areas of low pressure over tropical waters. A hurricane disrupts the tropical air masses and causes cloud formations and thunderstorms. Distribute a piece of construction paper, a marker, and 2 paper fasteners to each team. Have students align the paper horizontally in front of them and write hurricane on the upper left half. Have them list the characteristics of a hurricane below the heading. Next, remind students that tornadoes form over land. Surveys have shown that most tornadoes occur in temperatures above 65 degrees Fahrenheit and result from thunderstorms, or more specifically, cumulonimbus clouds. A tornado is a violently rotating storm with winds from 50 to 300 miles per hour that follows a narrow path, usually less than a half a mile wide. Tornadoes usually last less than 15 minutes, yet in that time, strong tornado winds have been known to lift houses and cars into the air and carry them hundreds of meters. A tornado is distinguished by a funnel cloud that stretches from the cumulonimbus cloud down to the ground. The tornado is a tight spiral of swirling winds that form a debris cloud at the base of the ground. Tornadoes begin in areas of low pressure, thunderstorms. The pressure in the center of the tornado is even lower than it is in surrounding air. This low pressure is created by the updraft of air caused by the rotating winds. Although hurricanes are the largest storms on Earth, tornadoes are the most violent. Have teams write tornado on the upper right half of the construction paper, and then list the characteristics of this type of severe storm below the heading. Ask teams to retrieve their weather stations. Write the heading Severe Storms on the lower left panel of the station and attach the chart below the heading. Next, show the video on hurricanes and tornadoes. Then discuss what the students saw. Distribute Activity Sheet 12 to each student. Have students determine what kind of storm is represented by the weather data presented on the activity sheet. Ask students, have you ever heard a weather broadcast that told of an approaching storm? Do you think it is important to notify people of an approaching storm? Why? Discuss how important it is to forecast a severe storm to those people in its path. Compare examples such as the hurricane that struck Rhode Island in 1938 and Hurricane Andrew, which struck Florida in 1992. Discuss how advances in forecasting and communication saved many people's lives. Explain to students that severe storms can be forecast and communicated to the people who will benefit from knowing that a severe storm is coming their way. Share information about the Red Cross and FEMA, the Federal Emergency Management Administration. When natural disasters approach areas where people live, FEMA broadcasts emergency information, including the best evacuation routes for the area being threatened. The Red Cross provides many kinds of disaster assistance and relief. Distribute any handouts you may have collected, and conduct a classroom discussion of emergency procedures. Tell students to secure their newest weather report on top of the other reports in the bottom center of their weather stations. Lead a discussion comparing yesterday's forecast with today's actual weather. Lead a discussion of the overall accuracy of the forecasts they collected for the past 8 to 10 days, and ask how accurate were the weather reports. If forecasts were sometimes wrong, it is important to understand why. There are so many variables that create our weather, including temperature, humidity, pressure, wind, and even pollution, that it is impossible to always predict how one variable will affect the next. Finally, discuss the students' forecasts. Ask, did your forecasts improve over time as more types of data were collected? Answers may vary, but students should recognize that collecting more data improves the chances of an accurate forecast. To conclude the activity, return the video to the kit. Have the students disassemble the weather stations and return the fasteners to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.